Today's lab activity is going to be doing exercises with chromosome mapping using gene crossover frequencies. A little background on crossing over. When homologous chromosomes pair up during prophase 1 of meiosis, there are some times where the legs of one chromosome will cross over with the other. These things will break off and reattach, forming recombinant chromosomes. These guys are not exactly like the original because that's part of the paternal with part of the maternal and part of the paternal with part of the maternal here. So it's recombined, giving different genetic combinations for the chromosome. Since this process is random, it doesn't completely follow Mendel's patterns of inheritance. Genes that are closer together, meaning they would be linked genes, are less likely to cross over. Genes that are further apart would be more likely to cross over. So if we're looking at our chromosome map over here, the gene for body color and wing size would be more likely to cross over than wing size and eye color because these guys are closer together on the chromosome. Now they would, and it shows the frequencies here, it's just less likely, meaning it won't happen as often. To make a gene linkage map, you're going to use the crossover frequencies, which are measured as percents, to make a map representing the distances between genes. Percentages are used to measure the distance between genes, and these distances are given the units, map units. Okay, so we have these different genes here. We have the distance from A to C, gene A to C, crossing over 30% of the time. From B to C, crossing over 45% of the time. From B to D, crossing over 40% of the time. And A and D, crossing over 25% of the time. So to create our chromosome map, we're going to use the percentages, right? The percentages, remember these are the same guys we had before, the same percentages, to construct a chromosome map. So we're going to use either millimeters or centimeters depending on how high these percentages are. We're scientists, so we're going to use centimeters. These are centimeters, okay? From here to here is 1 centimeter and 2 centimeters and 3, right? And in between, these guys are millimeters. So there are 10 millimeters to a centimeter. Okay, so we got that. And those are the units we'll be using for our exercise. So to make our chromosome map, we're going to measure on the line on your paper, on my graph paper here, 45 millimeters, because that is the longest, the highest percentage, and that is from B to C. And that is 45% or 45 millimeters. Next, we would go to the next highest one, which is B to D, which is 40%. So again, we'll start at B. This time we'll measure 40 millimeters. Okay, and that would put us at D. And that's 40%. Next would be AC, which is 30. So in this case, we're going to start at C and measure 30 to the left, which would put us at A. So that's 30. And finally, we have AD, which is 25%, which is the distance here, the distance between A and D. So now we just have to do some subtraction to figure out the rest of our map units, the rest of our distances for this gene. So for this, we can see this total is 45. Okay, from A to C, it's 30, and A to D, it's 25. So the distance between D and C must be 5 map units. 25 plus 5 is 30, and our total length is 45. So the distance between B and A is 15. So based on our chromosome map from the previous slide, the order of genes are B, A, D and C. And the distances between B to A is 15 map units. From A to D is 25 map units, and the distance from D to C is 5 map units. So once we have these distances between genes, we're going to mark this on our chromosome here so you can see where the relative positions are. So since our gene order is B, A, D, C, we're going to put this B right here and mark that because that'd be the most likely to cross over. The distance for between the next gene, A, is 15, so we're just gonna kind of approximate and just put this like at 15 map units, just so we have a relative idea. A to D is 25, so that's gonna be a little bit further. And D to C is 5, so that's gonna be relatively close right there. And we've mapped the positions of our genes on the chromosome. For example, 2, the percentages here, these are much smaller. I mean, these are a lot smaller, like, you know, less than 2.5% for the biggest one. Very not like Mendelian, right? Mendelians are 25% or 50%. They're going to be much higher percentage. These are super small. So because they're very, very small, we're going to have to use a bigger unit of measurement to spread out our diagram and make it easier to read. So we're going to use centimeters for this one. And then do our diagram with centimeters. Okay, so first things first, I have to fix this. This is actually WX, so that's an X. All right, so to start this, we start with the highest value, which is 2.4. So on our line here, we're going to measure 2.4. 1, 2, 4. Okay, and we're going to mark this end of it as W, and this end of it as Y, and that is 2.4. Next we go ZW, which is 1.9. So right about here. And this is 1.9. So if you see from 2.4 to 1.9, this is going to be 5. Between these guys is 5 map units. Okay, so we got that. And then finally, XW is 1. So we would go XW at 1, which makes this 1 unit apart. And then by just doing math, it's 2.4 total minus 0.5 makes it 1.9 minus 1 makes this gene 1.9 map units apart. Okay, so looking at that, we can...
Sophia Stower, please.
So on our chromosome here, our order is W, X, Z, Y, with W being closest to N. Now these guys are a lot closer together. So this is 1 unit apart, 1 map unit apart, so we're going to draw that very, very close, and that would be at X. And then 0.9, which is like almost the same. We're going to put that one at Z, and then finally, very close would be Y, and we labeled Y. Make this a Y. Label our chromosome. Okay, so on the rest of your handout, there's 3 more problems for you to do. Work those out. Refer back to these examples if you need to, and then answer the analysis questions and conclusion questions. If you don't get it done in class, finish it for homework and bring the written lab right up to class next time. Good luck.